As I'm adding this together, I want to start by regrouping, and I want to put the 2 and the 4 together, and then I'm going to put those imaginary terms, the 3i and the negative I together, so plus 3i minus I. And I'm doing this because my goal is actually standard form. I want the a first, a is just a real number, plus the bi, which is a real number times I. That's going to be my imaginary part. Well, I am just about there. So as I combine these, I've got 2 plus 4, which is equal to 6. And then I've got my 3i minus I. 3i minus I is going to be a plus 2i. We also want to be able to subtract, and our goal is the same. I'm going to move that negative inside the second set of parentheses, and we don't need the first set of parentheses. So let's start here. I've got 5 plus I, and then distributing that negative. Negative times 4 is a negative 4. And then negative times negative 2i is a positive 2i. Now I want to combine my real part, which is going to be the 5 and the negative 4. 5 minus 4 is equal to 1. And my imaginary part, which is going to be the plus I plus 2 more I, which is plus 3i. Next up is multiplying, and these feel so much like what you've learned with your polynomials. I'm going to be doing FOIL, so just as you've probably done before, we're going to distribute in a really specific order here, starting with first times first. First times first is 1 times 2, which is 2, and then outer is next, so outer is going to be 1 times I, so that's going to be a plus I. Inner is next. Inner is going to be negative 3i times 2, so negative 3i times 2. And then finally, last is going to be a negative 3i times an I, so there's last. Let's go ahead and clean up what we've got here. I have a 2 plus an I. I can multiply the 3 times the 2 here, and I get a minus 6i. And on the end there, I can write this as minus 3i squared. Now in standard form, we don't have an I squared, so we're going to use that part of the definition that says you can replace I squared with a negative 1. So as I work through what I've got, I can combine a little bit. I can take my 2, and let's combine these i's. I've got 1 I minus 6 of them. 1 minus 6 is negative 5 i's. And then on the end here, I've got negative 3i squared. But this I squared can be replaced with a negative 1. So we're pretty much there. I've got a 2 minus 5i. Negative times negative, now this becomes plus a 3. And combining those two real parts together, 2 plus 3 is 5. And our answer is 5 minus 5i. This one is really similar to the last one, but I want to start by writing what this means. It's 5 minus 2i times itself, so times another 5 minus 2i. And I'm going to go ahead and multiply in that same order, doing first times first. So that's 5 times 5, or 25. And then outer, 5 times my negative 2i. 5 times negative 2 is negative 10, so I get a negative 10i. And then in the middle, I'll put it here, negative 2i times 5. Negative 2 times 5 is negative 10, and I've got an I. And then I've got negative 2i times negative 2i. Multiplying those negative 2's together, I get a plus 4. And then those i's together, I get an I squared. But I'm again going to use the fact that I squared is equal to a negative 1. So I can replace this with a negative 1. Let's just go ahead and do that right in line here. So I've got a negative 1 here. So where does this leave us? I've got a 25. I can go ahead and combine my imaginary parts. So negative 10i minus another 10i, that's minus 20i. And then multiplying 4 times negative 1, that's going to be a negative 4. Finally, I can combine my real parts together, and putting this into standard form, I get 21 minus 20i. But what about division? Now, as I'm doing division, it's not going to feel like your traditional long division where you set up your division bar and go through it that way. Instead, it's going to feel a lot more like getting this into standard form. So the problem I've got here between this and standard form is my I, that 3i in the denominator. This is a nice one because we just have the imaginary part in the denominator, just that 3i. So I'm going to take care of this by multiplying an I in the denominator, and whatever I multiply in the denominator, I need to multiply in the numerator as well. Now this method only works with that single I term in the denominator. So I can multiply through my I into that numerator. So I times 3, that's going to be a 3i. And then I times my 6i is a plus 6i squared. In our denominator, I've got 3i times I, which is 3i squared. Now I've got a couple of I squareds here. So I've got one in the numerator and one in the denominator. I know that I can replace both of these with a -1. So I'm going to go ahead and erase that and replace both of those with a -1. So a -1 there, a -1 there. And we've got, I'm going to start to put my numerator in standard form. So I want the real part first. So that's going to be a -6 first, plus a 3i. In my denominator, I have a -3. Now I'm just about there, but I don't want that fraction bar. I know that both the -6 and the 3i need to be divided by that -3. So plus 3i divided by -3. -6 divided by -3 is a +2. I can cancel my 3's here and I get a -I. But what if your division doesn't just have the I term in the denominator? I'll show you what to do here.